This lesson is about writing linear equations. Okay, which equations represent a line that is perpendicular to this one and pass through this point? Okay, so there's a couple things we have to talk about before we start actually doing this. First of all, we have to talk about parallel and perpendicular lines. So parallel lines. Do you understand that parallel lines are lines like these that never touch? Okay, now if we're talking about slopes, if I told you that the first line has a slope of 2/3, do you know what the second line would have a slope of? 2/3. Alright, parallel lines are always going to have the same slope. So that's thing number one. Put that in your brain. Okay. Now, perpendicular lines. Alright, so first of all, you have to understand what the word perpendicular means. If you have two lines that are perpendicular, that means they meet at a 90-degree angle. Alright, so if these are perpendicular, that is 90 degrees. Okay, now let's talk about slopes. In fact, let's see. Alright, perpendicular lines, they don't have the same slope. Okay, their slopes are opposite and reciprocal. Opposite and reciprocal. Now let's see what I mean by that. Okay, if the green line had a slope of 2/3, do you know what the reciprocal of 2/3 is?
The opposite?
Well, what do you mean by that? Tell me what the reciprocal of 2/3 is.
0.6 or like 3/2?
3/2. Okay, the reciprocal is what you get when you turn this fraction upside down. So the reciprocal would be 3/2. Okay, so that's the reciprocal part. Now let's talk about the opposite part, because it's supposed to be both opposite and reciprocal. The opposite part means that one is positive and one is negative. So if the green line is positive 2/3, a perpendicular line will be negative 3/2. Reciprocal, but also opposite sign. Okay, let's look at a couple more examples. Okay, let's say if the green line had a slope of 3. Now let's talk about the slope of the pink line that's perpendicular. First of all, what's the reciprocal of 3?
1/3.
1/3. But again, it's got to be also opposite sign. So if the first one is positive, this one has to be negative 1/3. Okay? Let's do one more example. Okay? Say if this pink line had a slope of, let's say, negative 1/5. What do you think the slope of the green line would be?
+5.
Positive 5. That's exactly right. Okay? So that's something that you needed to understand. Okay? So make sure that's like in your notes or something. Let's see. Here's something else you need to understand. Alright. I have this yellow line and I have this pink line. Alright, even without any numbers or anything, one of these lines has a positive slope and one of them has a negative slope. Can you tell me which one of these lines has a positive slope?
The pink one.
The pink one. Okay? The pink one has a positive slope and the yellow one right, it's all about, are you going uphill or downhill? If you imagine going from left to right across the screen, for the yellow line you would go downhill, and then for the pink line you would go uphill. Alright, because this is downhill, that's negative. Because this is uphill, that's positive. Okay, that's important. Okay, so you had to have all of that in your brain. Okay, perpendicular lines, opposite and reciprocal. Parallel lines, same slope. Okay, okay, but that's just the beginning. There's more. There's more. There are two more things you need to know for this unit. There are two forms of linear equations. One of them is called slope-intercept form. That's right. Slope-intercept form is your y equals mx plus b. Okay, and so in this form, this is a slope and this is the y-intercept. Okay, so for example, if you had an equation like y equals 1/3 x minus 7, the slope is 1/3 and the y-intercept is -7. Okay, got it? Alright, now that was slope-intercept form. But there's another form that is called point-slope form.
I take away y1 equals m, and then parentheses x minus x1.
That is exactly right. Let me try to do this the exact same way. Yep, you got it. Point slope form is y take away y1 is equal to m times x take away x1. Okay, in this form, this is still the slope, and in this form, this is a point. Okay, these two are the point x1 comma y1. That's why they call it point slope, because there's a point and a slope. So a little example of that would be like if I had y minus 3, and then say if I had 2/5, and then say if I had x, and just to make it interesting, I'm going to say x plus 2. Okay, if I had this, that would mean that the slope would be 2/5. The slope would be 2/5. And the line passes through a point. Okay, now watch how the point is just going to be the opposite of these. So see how this looks like a -3? So the point would be +3 and then comma -2. Okay, so that's the background that you needed to know to be able to even begin to do this problem. So let's get started. So first of all, they're talking about perpendicular to this line. Well, we need to know what the slope of this line is, so we can do a perpendicular slope. So let's see, if I want to find the slope, I need to rewrite this equation. So I've got 5x minus 2y is equal to negative 6. I'm going to solve this for y. So I would subtract 5x from both sides. So that will give me negative 2y is equal to negative 5x minus 6. And then I'm going to divide everything by negative 2. So that's going to give me y equals, notice the negative divided by negative is a positive. So I'm going to say positive 5 over 2x plus 3. Okay. Now, so this is the same as the original equation. Now, this is not the line that we want. We want a line that is perpendicular to this. So look, all we really care about is the slope, 5 over 2. The rest of it doesn't matter. Alright, none of that matters. The 3, the y-intercept, that doesn't matter. I don't care. All that matters is that the original line that they gave us had a slope of 5 over 2. Now they're telling us they want a line that is perpendicular. So remember what we talked about on the black screen. If one line has a slope of 5 over 2, what will be the slope of a perpendicular line?
Isn't it perpendicular the same?
No, that's parallel, right? If they're parallel,
Oh, then 2 over 5.
2 over 5, and something else has to change. Negative, all right? The first one was positive, so this one has to be negative. So negative 2 over 5. Okay? So, for sure, the line that we want is going to have this slope. So let's see if we can throw any out. So see, this one has a slope of positive 5 over 2. So we definitely know that that's not going to be it. This one is possible because it has the right slope. This one is possible because it has the right slope. Okay, these two are possible. I don't know about these yet. Okay, but let's keep going. So far we've eliminated one option. It can't be this one. But we have to keep going. They gave us more information, but I need more space, so I got to erase. Okay, they gave us a point. So now, take a look. Now we have the slope and we have a point. What does that remind you of? If we have the slope and a point, that would be a good time to use point-slope form. If you have the slope and a point, why not use point-slope form? So that's what I'm going to do. I'm going to use point-slope form. Okay, and remember, point-slope form went like this. Y minus a particular y is equal to slope times x minus a particular x. So this is going to become y. Okay, now this is my y value, negative 4. But you sort of change the sign. So it's going to become positive 4 when you put it in. The reason why is because it's going to be y minus negative 4. And do you know how to do minus and negative?
Positive.
A positive. That's why it becomes y plus 4. So basically when you put it in, it changes signs because of that. I thought I had. Okay, and then comes the slope. Alright, our slope is negative 2/5. that we found. So we'll do negative 2/5. Okay, and then we have to do x minus 5. Okay, so this would be a point slope form of our equation. And that's exactly what they have right here. So that's definitely one of the answers. That's definitely one of the answers. Okay, now to check the rest of the answers, I need to sort of rewrite this without the parentheses. Okay, so what I have to do is I have to do the distributive property. So that's going to give me y plus 4. If I do the distributive property, I get negative 2/5 x. Now I have to do negative 2/5 times negative 5. Now I know that that's going to be positive 2 because I can do that in my head. But if you can't do that in your head, like many students can't, then you would do it in your calculator. So you could do negative 2/5, okay, times negative 5. And that's going to give me positive 2. Are you with me so far?
Yep.
So I just did the distributive property, and now I'm going to subtract 4 from both sides. Okay, so that's going to give me y equals negative 2/5 x minus 2. Once I put these together, it makes minus 2. Let's see, is that one of them? Okay, that matches this one. So that's an answer. Okay, what about these last two? Well, notice these last two don't have any fractions in it. If you want to get rid of a fraction, what you need to do is multiply by the denominator. I see 5 in the denominator. So what I'm going to do is I'm going to multiply everything by 5. Okay, that will have the benefit of canceling out the 5 in the denominator. So, okay, that gives me, so now I have 5y is equal to negative 2x minus 10. Okay, and so we're writing this in standard form with x and y on the same side. So I'm going to add 2x to both sides. Alright, so that cancels out. So that will give me 2x plus 5y is equal to negative 10. Okay, so that's 2x plus 5y equals negative 10. That's why this is another answer. But this one is not, because it has minus 5y and it should be a plus. Alright, so that's why those three are right and these two are wrong. Now, what is the equation in slope-intercept form of the line that's perpendicular to this one? Alright, so remember, if we want slope-intercept form, that's y equals mx plus b. Okay? They're saying perpendicular. Alright, so let's do that again. So the original slope is right here, of course. Alright, that's negative 2/3. If you have a perpendicular line, which is what we want, what's going to be the slope of a perpendicular line? Are you thinking?
Wait, what?
Ha! Pay attention. What I said was, if you have a slope of negative 2/3, that's your original line, what will be the slope of a perpendicular line?
Positive?
Positive what?
3/2?
Positive 3/2. So that's our slope. Our slope should be positive 3/2. So right there, that tells us that we have like y equals 3 over 2x plus something. Okay? So can we throw out anything just based on that?
Yep.
Okay, like see this? That's wrong and that's wrong. So it can't be either one of these two. So it's got to be one of the last two. But we need the b to figure it out. Okay, so here's what you can do. Now that we have the slope and a point, we could do the point slope form again. All right, so here we go. Remember, point slope form, y minus y, slope x minus x. So this is going to be y. Okay, here's my point. And notice that these will sort of change signs. So this will become plus 2. And the slope is 3 over 2. And again, it sort of changes signs. So are you with me?
Yep.
And then again, I'm going to do the distributive property. So that'll be like y plus 2 is equal to 3 over 2x plus. This is going to be 3. But again, if you're not sure, use your calculator. 3 over 2 times 2. 3 over 2
3.
times 2. Now I know that that'll be 3 because the 2's cancel out. Okay? So that's why it's 3. And then I just subtract 2 from both sides. So that gives me y equals 3 over 2x plus 1.
Okay.
Okay, that's why it's the last one. Okay, this line passes through these 2 points. Okay, great. What's the equation in point slope form of a line that's perpendicular to this line and passes through the point blah? Okay, so they're using this word again, perpendicular. So that means we need to do the thing we did before, where we have a slope and then we have a perpendicular slope, and then we go with the new one. So first of all, let's look at this and find the slope. Now if we didn't have the graph, we could just do the slope formula and do like y minus y over x minus x. Alright, but we have the graph. So by the way, look at this picture. Is this line, does this have a positive slope or a negative slope? This has a positive slope, so just be sure that whatever else we do, the slope better come out positive. So I'm going to travel from one point to the next doing my rise and run. Now here's what I see. Do you notice that it hits right on the grid at these points? And like right where the lines cross, it's touching. So that helps me see. It's going up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. That tells me that the slope is 1 over 2, rise over run, up 1 over 2. Does that make sense? Now, like I said, I could have gotten that using the slope formula, which is y2 minus y1 over x2 minus x1. If I had done that, that would have been 1 minus negative 3, which would be 1 plus 3, and then it would be 4 minus negative 4, which would be 4 plus 4, and that would be 4 over 8, which would be 1/2. But for me, if they give me the graph, it's so much quicker just to do up 1 over 2. Okay, anyway, if this is the slope of the original line, what will be the slope of a line that is perpendicular to this one?
2 over 1.
2 over 1. Okay, negative 2 over 1. And we could just say -2 because we don't need the 1 when it's on the bottom. Okay, so this is our slope. Alright, so hang on to that, slope of -2. So we have the slope and we have a point. If we have a point and the slope, it would be very easy to do point-slope form, which is what they want. So remember, point-slope form will go like this. It will go y minus y, so that'll be y minus 3 equals the slope. And then we're going to do x minus x, but because this is already a -4, when you subtract a -4, it's the same thing as adding 4. So this would be an equation in point-slope form. Okay, I have this equation in, this is called standard form, by the way. What is the equation in slope-intercept form? Okay, that's y equals mx plus b, that's slope-intercept form, of the line that is parallel to the given line and passes through the point 0, 12. Alright, first of all, we need to know what the slope of this is. Okay, the way to find the slope is to rewrite this in slope-intercept form. So I'm just going to recopy this. So I have 10x plus 2y is equal to -2. I'm going to solve for y. So I'm subtracting 10x from both sides. So that gives me 2y is equal to -10x minus 2. Okay, now I'm going to divide everything by 2. So that's going to give me y is equal to -5x minus 1. Okay, so I haven't answered the question yet. I've just rewritten the original equation. So this is still the original equation. Okay. Now, I only care about one thing from this, though. All I care about is the slope, because then I'm going to talk about a parallel line. All right, what is the slope of this equation, the original equation?
1.
No, that's the y-intercept, would be -1. What's the slope? -5. Yeah, the slope is the m of y equals mx plus b. M is the slope. The slope is -5. Okay. Okay, so the original slope is -5. Now, tell me again, what will be the slope of a parallel line? No, not +5. Parallel lines have the same slope. -5. Because think about it. You know that this is what parallel looks like, right? They're both going the same way. If the first one has a slope of -5, you know that it's going downhill because it's negative. If it's parallel to another line, all right, let's say it's parallel to this green line. If they're parallel, they both have to be going downhill. All right, if one was going uphill, they wouldn't be parallel, right? So if they're both going downhill, they're both going to be negative. So they have to be exactly the same. So that means we have our slope. Our slope is -5. And guess what else? We have the slope and a point. Okay. All right, if we have the slope and a point, we can do point-slope form. So that's point-slope form goes like this. Y minus y, so that's y minus 12, is equal to the slope, and then x minus x. Okay, that's x minus 0. Alright, so that's just y minus 12 is equal to negative 5x, because it's 0. You don't really have to write the 0. Are you with me so far? And now I'm just going to add 12 to both sides. So that's going to give me y equals negative 5x plus 12. Alright, so that would be the answer. Okay, what is the equation in point-slope form of a line that is perpendicular to the given line and passes through this point? So this is exactly like other problems that we've done. So once again, let's set up our little comparison. Alright, so first we need to find the slope of the original. And again, I could sit here and go y2 minus y1 over x2 minus x1. I could do the numbers. But when they are kind enough to give me a graph, it's usually easier just to count. Oh, by the way, is this a positive or a negative slope that I'm looking at? It's negative. So whatever else happens, it's going to be negative something. Okay. Now, let's see. I don't see any points in between here where it hits right at the grid. So I'm just going to do the whole thing. It goes down 1, 2, 3, 4, and over 1. Did you see that? Down 4, over 1. So that's negative 4 over 1, if you will. I could have just said negative 4, but it's like negative 4 over 1. Now, what will be the slope of a perpendicular line?
Positive 4.
Positive 4. Positive 4. So this is the one that we want. So that's our slope. So keep that in your brain. Our slope is going to be positive 4. Now, they also gave us a point. Alright, so we have a slope and we have a point. Okay, negative 4, comma, negative 3. If we have the slope and we have a point, we can do point-slope form. So that's what we're going to do. Okay, point-slope form goes y minus y. It's already negative, so it's going to become positive. Is equal to the slope, which we decided was positive 4, and then x minus x. Alright, since it's already negative, when you subtract, it will become positive. Let's see. Is this the answer, or do I need to distribute? Well, that depends on what form they asked for. They asked for point-slope form. So am I going to leave it like this or distribute?
Leave it like that.
Leave it like that. This is point-slope form. So that's it. This is the answer. Okay? Okay, so we have this picture. We have a couple points on the graph. What is the equation of the line that is perpendicular to and has the same y-intercept as the given line? So anytime they ask you to write an equation, there are two things that you need. You need the slope, and you need a point. Okay? If you have the slope and a point, you'll be able to write the equation. Now, when you see this word, perpendicular or parallel, they are indirectly giving you the slope. Okay? If they say parallel, they mean take the line or equation that you have and just keep the same slope. If they say perpendicular, then they mean take the line or equation you have and do the opposite and reciprocal slope. Okay? So they said perpendicular, so let's look at the line they gave us, figure out the slope. Since they said perpendicular, we'll switch it to be opposite and reciprocal, and that'll be our slope. We already have a point because they said it has the same y-intercept as the given line. So this is the y-intercept right here, 0, 1. So we have the point 0, 1. Not only that, because it's the y-intercept, when we talk about y equals mx plus b, because it's the y-intercept, it's specifically giving us the b, which makes it easier. So we know that b is 1, alright, which basically narrows it down to it has to be one of these. Okay, because these are the only ones who have that y-intercept, that b value of 1. So all we really need is the slope at this point. Okay, so looking at the given line, first of all, this line that's been graphed, does it have a positive slope or a negative slope?
It has a negative.
It has a negative slope. So I always like to say that first before I do anything else. So the original one is going to have a negative slope, which means when we do the opposite and reciprocal, that one will have a positive slope.
Yep.
Alright, both of these are positive anyway, but still. So as I go from left to right, I'm thinking rise and run. It's going down 1 and over 5. 1 and 5. That's the rise and the run. Vertical over horizontal. So that makes this slope negative, of course, 1/5. Okay? So if the original line has slope of negative 1/5, what will be the slope of a perpendicular line?
That would be 5.
That would be 5. Alright, so that tells us that it's going to be the second one.
Yep.
Let me say one more thing before we declare victory on this problem. They gave us the graph so we could just count the squares like this. They also gave us these 2 points. They didn't have to do both of those things. They could have just given us the points. Okay, 0, 1 and 5, 0. So I want to make sure you understand how to find the slope even if they don't give you a picture. Okay, because just remember that the formula for slope is y minus y over, yeah, exactly. Okay, so we could have used that if we had wanted to instead of counting squares, or to double check if we weren't sure.
So they didn't give us the graph.
Yeah, exactly. If they just said blah blah blah, instead of giving the graph, they could have said, you know, passing through the points 0, 1 and 5, 0. Give me the equation of a line perpendicular to that. That's all they had to say. Just by mentioning 0, 1, that is the y-intercept, so they wouldn't have had to say anything about that. So if we did that, y minus y, that would be 0 minus 1. And then x minus x, that would be 5 minus 0. So that would be negative 1 over 5. So that's another way we could have gotten this even without the graph.